What's up guys, Onmaths here, and we're going to start off with Edexcel on compound measures, and this is obviously a question about speed. And whenever you've got a question about speed, always remember your triangle, and most teachers teach it this way. If you don't know about the triangle, you just put in speed and time at the bottom, and put in distance at the top. And what the triangle reminds you of is if you have one of these, so we're going to cover one up. Let's cover, time up. So if we cover time up and we're looking for time, the triangle shows us that we do distance over speed, right? If we're looking for speed, cover that up and it says distance over time. And finally, if we're looking for distance, we just do speed times time. Okay, and these triangles are really useful. There's loads of areas of maths that you can use triangles for. Right. First thing with this question is to kind of understand what's going on, and sometimes it's easier if you just draw a quick diagram. So we're going to have James here, and this line's going to represent his kind of route, right? So we've got time is 2.5 hours, okay, and distance, which we use S, but I'm just going to, let's use S. Let's use D. So distance is 50 kilometers. Okay, so here's this quite straightforward, and we can already start to think about how we're going to answer his bit. The less straightforward part is Peter's. Now, Peter, we don't really know how long it took him for the whole thing, but we know the 15 kilometers. So 15 kilometers. So we kind of need to know kind of James's time for his 15 kilometers as well. And then we can compare them. So we've got a lot to find out here. And I think the first thing we're going to do is work out James's speed, because we kind of need to know at what time James reached 15 kilometers so that we can work out Peter's speed. So let's work out James's speed. So we're going to just show the examiner that I'm looking at James, and we're going to work out his speed. And we know his distance was 50 at the end, so it's 50 over his time, which was 2.5. And you might notice this is a non-calculator paper, so what I can do with this fraction is times top and bottom by 4, so that would be 200 over 10, and then obviously 200 divided by 10 is 20, so that's a bit of an easy way of doing it, and that is kilometres per hour, because the 50 is in kilometres and the 2.5 is in hours. Okay, so now we need to work out James's time, so time at 15 kilometers. So time is distance over speed. So we've got his distance is 15 kilometers, and his speed we've just worked out is 20. And then divide top and bottom by 5, and you get 3/4. Now, given I know what's going to happen or what we're going to have to do next, it's important to realize this is in hours, and it might help us to convert that into minutes. Now, 3/4 of an hour is not 75 minutes, which a lot of students accidentally do. There's not 100 minutes an hour, there's 60. So if you think about a clock, 3/4 of an hour or a quarter of an hour is 15, so 3/4 of an hour is 45 minutes. You'll see why I've converted it in a second. So now we're interested in Peter. Now we know that if you read the question, it says that Peter started to cycle 5 minutes after James started. So what we now need to do to work out Peter's time, and we're going to show the examiner we're working with Peter now. So the time at 15 kilometers is going to be the time James took to get to the 15 kilometers, and I might as well just put it on here and show the units because they're not the same. it's the time that James took, and then obviously we're removing 5 minutes because James had a 5 minutes head start. So 45 minutes, take away 5 minutes, which would be 40 minutes. And I don't often put units in my working out, but here, because we're working in minutes and hours, I think it's really useful to have the units in. Okay, so now we need to convert that into hours, because we probably want Peter's speed in kilometers per hour, and if you look in the question, it wants it in kilometers per hour, so we just need to convert it back. So all minutes are over 60, so if we just put this over 60, and then divide top one by 10, and divide top one by 2. So it's 2/3 of an hour. And so the time is 2/3 of an hour. And you can see with the triangle, if you know two things, you can work out the third thing. So all we need to do now is work out the speed. I'm kind of running out of room here, so I'm just going to use here. So speed is distance over time. So it's 15 over 2/3. Now you can see we've got a fraction within a fraction. If we just look at this one here, okay, and instead of a fraction we do it as a divide, this is actually quite an easy one as long as we know the rules. So instead of writing 15 over, we write 15 divided by 2/3. And the KFC rule, if you don't know what that is, check out our fraction video. Means we keep the first one the same, we change the divide to a times, and we flip the second one, 3 over 2. Okay, so now we've got to halve the 15, because you divide by the bottom of the fraction, so that would be 7.5 times 3. And 7.5 times 3, well 7.5 times 2 is 15, as we know, then add on an extra 7.5 would be 22.5. So the answer is 22.5 or 22.5. Not the easiest question at all. Lots and lots of understanding how to actually calculate things, and that's why it's really important. With a higher paper, some students feel that they don't need to know like the really basic, like working out side of it and using fractions and stuff. And it's really important you know that stuff, because on the higher paper it's just assumed you know it. So if you don't, just spend some time working on it now. Okay, now we have a bit of a change of pace with AQA, because this is actually a very simple question. All you need to know with this is the triangle. So let's draw the triangle out. And with density, so density, you've got volume at the bottom, and you've got mass at the top. Now with this question, if you didn't know that, you can actually look at the compound unit, which is density, and it says kilogram per meter cubed. Well, kilogram is a unit of mass, meters cubed is a unit of volume. So it's telling you there that kilograms go on the top and meters cubed go at the bottom. So mass goes at the top, volume goes at the bottom. So with this, we're working out the mass. So we're just going to write mass equals density times volume, and the density is 2,400, the volume is 3.8, and we have a calculator for this. So 2,400 times 3.8 is 9120, so it's 9,120. Finally, we move on to OCR's offering. Now, question A is actually very simple, and you can kind of see why it's a question 1 in the exam. Question B is anything but simple. So let's get started with question A, and let's get that answered. So it's to calculate S, and it's got a Suvat equation. And if you're using Suvat equations, you are given them in the paper, not at A level. So you might want to learn them now. So here it says U times T, so it's 5 times 10. Plus half times A, which is 3, times T squared, so that would be 10 squared. Now this is on the calculator paper, so all I'm going to do is put that into my calculator and just work out the answer. So it's 200 Simple as that. The answer is 200. So you can see why that's question 1. That's nothing difficult, especially in a calculator paper. But then it says make A the subject of the formula, which is not the nicest question to do. And if you struggle on this one, we are going to do a video on rearranging formulae. And we're kind of only doing this because it's a Suvat equation and that goes in this topic. Right, so we've got to get A on its own. So the first thing we're going to do is just take away that UT, and we're just going to take away it together. So we're going to have S minus UT, and that just means that we've only got one term to deal with. Now, what I can do is I can divide by a half to get rid of that half, or I could just times both sides by 2, which actually might be easier. So I'm just going to times both sides by 2. And I could deal with the t squared as well, but I'm not. I'm just going to break it down into 2, and you'll see why in a second. So times that by 2. So we've got to times the whole thing by 2. And then we're left with at squared. And then final thing is we're just going to divide by t squared to get rid of that t squared. Now when you divide, you can just put the whole thing over it. So 2 brackets s minus ut over t squared equals a. Now what you can do is you can expand the bracket at the top, but there's just no need to, because actually a factorized version of it in a lot of ways is better. Like, you're always told to factorize, and make things simpler. So there's absolutely no need to, and that would be full marks. Well, I hope you liked this video. If you did, please click like. It really helps us out. If you've got any comments on today's video, obviously write them down in the description. And if you want to see more from us, we release videos every single weekday, Monday to Friday, at 9 o'clock in the morning. So just click subscribe and click the bell thing to make sure you're up to date with it. If you want to see more resources from us, we have a massive website with every single topic and loads of free stuff. Everything there is completely for free. Even signing up is free. That saves your scores and all of that jazz. A card will magically appear above the video now. Just click on that. It'll take you straight through to the website. Otherwise, I'll see you tomorrow. Or probably then Monday.